Okay, so thanks a lot, Sam. Is my screen visible?
Yep, and we can hear you too.
Okay, perfect, perfect. So yeah, so I guess we all set to start. Okay, so yeah, so hello everyone, and welcome to the presentation on hacking IoT for bug bounties. And thanks a lot to Sam and the entire Bugcrowd team for having me. And I think this session will be extremely informative for anyone who wants to start IoT bug bounty hunting or in general looking into IoT devices to find security issues. So my name is Aditya and I hack IoT devices for a living. So that is pretty much all I do like throughout like all over my professional career. So looking into all sort of different IoT components, hardware, embedded devices, radio communication, mobile application, all of that, and also fitting all of those pieces together in order to look into the IoT security as a whole. So a bit about my background. So I run Atify, where we pen test IoT devices for a bunch of different companies. I'm also the author of a couple of books. One of them is Learning Pen Testing for Android Devices, which came out like 2 or 3 years back. The other one is coming out this month called IoT Hackers Handbook, which is pretty much how you can get started in IoT hacking and find like pen test IoT devices and so on. I've also spoken and trained at a number of other conferences like Black Hat, DEF CON, all of that. Later on in this talk, I'm also going to release something called as IoT Pen Testing Guide, which I started working on a couple of days back. And I think it would be nice to have sort of like a step-by-step testing methodology on how you can start looking for vulnerabilities in different aspects of IoT devices. So for someone who is absolutely new, how you can pretty much start on your own. And I've also developed a couple of training courses and released a bunch of videos, build Artify store, and so on. Right. So let's jump straight into the presentation. So what this presentation contains, so we'll start off by looking into why you should actually be caring about IoT security, because frankly, I don't see a lot of people or security researchers looking into IoT security as of now, especially given the fact that it's so easy at this moment to find IoT security vulnerabilities because manufacturers are not making secure products. So we'll look into that, and then we'll move into what kind of security issues should you look for, and finally how you should identify those vulnerabilities. Right. So if you're forming IoT bug bounties as of now, you're missing out on something really, really great. So if you look at the current scenario in 2017, there are a number of IoT products coming up every month in the market. A number of vendors are getting onboarded on bug bounties for their IoT devices. And if you look at the entire like entire security community who perform bug bounty, most of them are focused into the aspects such as web application, mobile application, or other sort of security domains, but not specifically looking into things like hardware or radio communication or various other approaches to pen test IoT devices and find vulnerabilities in it. So that is why it makes it an extremely lucrative target for you. And especially if you also look at the entry barrier, I think that is something that is keeping a lot of security researchers from entering into this particular field. But to be honest, if you know how to start, then starting up is extremely easy. And that's exactly my goal with this presentation, to give you an idea of what exactly you need to do in order to start IoT bug bounty hunting. So a couple of previous examples. So an IoT fridge was hacked, and since it was connected to your Google accounts and the email accounts, it was used to send a bunch of spam. Also, a couple of vulnerabilities in smart home devices, smart home IoT devices, through which the entire home was able to be compromised. Then there's this interesting medical device update utility, which used encryption to ensure that they were pretty secure. And if you reverse engineer the mobile application, you would find the password as Bob the Builder. Uh, yeah, that's a medical device update utility. Also, I assume everyone is familiar with Shodan. So If you look at Shodan, you'd find a bunch of various IoT devices exposed to the internet, be it like critical infrastructure like SCADA systems, or be it things running MQTT instances, or be it smart home devices, or be it like ridiculous devices like dishwashers or refrigerators or smart TVs or egg trays. All of that is being exposed to Shodan. And yeah, as you could have guessed, like pretty much without authentication or with using the default credentials. Also, someone found a truck parked somewhere using Shodan, and he tried the default credential, and he was able to move the truck remotely. So this is this just signifies how critical IoT security is and what is the current state of IoT security as of now. So now that we know that IoT security is in extremely poor state as of now, what can you actually do in order to figure out these security issues? Because you read about it in some of the media articles, maybe like this particular device was hacked or this particular bug was discovered. But what is the systematic approach that you can use in order to figure out those vulnerabilities? So that is what we are going to be discussing now. So the first thing is, whenever you look at the device, uh, you should look at it from a pen tester's perspective. So I assume like you might be already familiar with like web application or mobile application. So you get the mobile application or web application, you run a couple of scanners on it, you do a bunch of manual security analysis, you figure out how things work. So take the exact same pen testing mindset and look at an IoT device. So if it's a smart home, think of what are the different components in a smart home. What are the different entry points? How is it communicating via, like, how are the sensors and the hub communicating with each other? Or what sort of protocol it is using? Or what are the different expose ports? So think about all the different ways in which you can actually just try to compromise the device, right? So you don't actually need to compromise the device as of now. You just need to think of all the various ways in which you can actually do it later on, right? So having the initial pen tester's mindset is extremely useful. So also another thing in IoT, which is pretty different from most of the other security aspects, is you don't have just a single component. IoT is both. So in order to look at IoT, you have to look at both the micro and the macro. So micro being all the smaller components, which is like the sensors, the embedded device, the firmware, the radio communication, all of that, and the macro being putting all of those pieces together and looking at how it operates overall, and if there are any possible security issues if you look at the overall picture, right? So that is what you should do once you have the target. Now, how you should actually do it. So how to actually find vulnerabilities which are critical for the companies, which can actually help companies secure their devices and for which they will actually pay you bounty for. So a lot of people, when they get started or try to get started in IoT, assume that it's like so difficult to get started. Like it's all hardware. I need to know a bunch of electronics. I need to know digital signal processing. I need to know this and that. But to be honest, like based on the past couple of years, when I have done like over like maybe around 200 or so pen tests, hacking IoT is not a black magic. Like, even though I come from an electronics and communications background, and that proved to be a bit helpful, but I wouldn't say that if you don't have an electronics background, you wouldn't be able to do it. So it's something which can be learned. And the only problem being that there are so many less resources. And yeah, thanks for someone who commented on the slides. Yeah, thank you. So there are so many less resources available, and that is the only limiting factor which I see as of now. And that is also the reason I mentioned in the very start, I'll be releasing a pen testing methodology at the end of this talk. So there are 5 components in IoT bug bounty hunting or IoT pen testing. So the first is attack surface mapping, looking at the entire picture, figuring out all the individual components. Then we start off with embedded device hacking, which is pretty much looking at the hardware, figuring out all the serial ports, look like all sort of hardware hacking techniques. Then we start with firmware hacking, which could prove to reveal a bunch of sensitive information. We'll get to see in this presentation. Then your usual mobile web and cloud component pen testing. And finally, looking at the radio components or the radio communication. And there is a specific reason why I have mentioned the embedded device at the first and then after that hacking firmware. It's because a lot of times the firmware might not be available to you. And it's the embedded device which can actually make the firmware available to you. Like you can dump it from the device. Yeah. So just to answer the question quickly over here. So someone asks if most IoT devices are vulnerable, why do companies have security team? What exactly is the problem? So the answer to this question is even though a lot of new companies or a lot of companies who are manufacturing IoT devices, they are starting to build their security teams. Even then, their security team is not that mature as of now. That's what I have realized working with a lot of companies in the past, that they seem to have a bit of information that what to protect and what kind of things to actually look for, but they don't but they kind of lack the insight of IoT security, and that is the reason why they fail at a number of places. Like I was testing a smart home solution a couple of weeks back, and they implemented CRC, but the CRC verification mechanism was somewhat broken, and we were able to actually crack the CRC and do things like replay attacks and all of that. So yeah, so the security teams are there, but I think they need to improve, right? So attack surface mapping, what do you actually do in attack surface mapping? The basic recon, look at the device. Are there any visible ports? Is there things like Ethernet port? Is there like SD card port or any other external storage or any sort of other things that you can pretty much identify from the device? So all those kind of reconnaissance. And then you look for all the publicly available information. So things like data sheets, FCC ID, try to grab as much information about the device as possible from the support groups. So in some of the cases, what I've also seen is even though the firmware is not available online on the vendor's website, you can actually jump into a conversation with a couple of guys on the support groups, and they will be willing to provide the firmware which they might have extracted from the one of the previous versions. So yeah, so all of that is pretty helpful. The next step of attack surface mapping is to pretty much look at all the different components. So if we talk of, let's say, a smart home solution, so it will have like a light bulb, a smart socket, and a smart home hub, and then it will have a mobile application. So figuring out or mapping out all the different individual components and how each of them interact. So there could be vulnerabilities in each of the components as well as their interaction. So those are both the things that you need to focus on. So this is kind of an architecture diagram I drew in order to look at the overall like an IoT ecosystem from a security perspective. So you have the IoT gateway over here, and so this is the IoT gateway, which communicates with the devices and the mobile application and also with the cloud and web dashboard. The mobile application can have its own set of security issues. The device can have its own set of embedded device related security issues. And the cloud and web will obviously have those security issues. Now, apart from that, the protocols that it uses for communication, let's say Zigbee, Z-Wave, 6LoWPAN, LoRa, all of that, or even things like BLE or Wi-Fi or Ethernet. So all of those can also have their own set of security issues. So that is also something that you should focus on. Right? So just to give you a quick example of how to do a basic recon. So this is a Philips Hue hub, which I have at my home. And if you look at it very closely, there's an FCC ID that is mentioned over here. Now, FCC ID is a kind of ID which every manufacturer has to get in order to sell their products in the United States if their device is doing some sort of radio communication. So a lot of IoT devices, since they use radio communication, you'll find FCC ID on back of them, right? So if you look at this particular FCC ID, uh, and if you quickly go to fccid.io, is my Google Chrome browser visible? Let me check. No. Okay, just a second. Uh, Yeah, I think it should be visible now.
Yep, it is.
Yeah. Okay, perfect. So if you just look up the FCC ID, this is what you get. So you get the exact frequency range on which it operates, the RF exposure, the letter of agency, external and internal pictures. If you just go to the internal pictures, you'll find out how the device looks internally. So even before actually purchasing the device, you can just have a look at the device in the store, note down the FCC ID, and you'll be able to look at the device internal circuits, figure out whether it has any maybe JTAG or UART ports, or whether it has an SPI flash, or what kind of components it is using, all those kind of information, right? So this kind of basic recon is something that is very useful in performing like any kind of security research, right? So jumping back to the presentation. So once you have identified, like did a basic recon, what to do next? So oftentimes in IoT, one of the components leads to the next. So like I mentioned, if you look at the IoT device, it can actually help you get the firmware of the IoT device. So you can actually dump the firmware of the IoT device solution from the SPI flash or any kind of flash chip from the device. And once you have the firmware, you can pen test it like you do any normal Linux box, right? So how to approach IoT devices? Start with embedded device, then go to firmware, web, and mobile, and then finally move into all sort of communication related topics, right? So we'll start off with embedded device hacking. So embedded device hacking, if you have never worked with hardware before, it might appear to be a bit daunting at first, but this presentation will help you erase some of that fear which you might have in your mind, right? So the first thing, whenever you get a device, you just simply go ahead and open it, like you would do in any, like if you like working with electronics, I think you would already be doing with any device that you have. So open up the device, look for any kind of physical tampering protections. So different devices might have different physical tampering protections. So for example, one of the device I was pen testing. So as soon as you open up the device, one of the buttons get clicked and the entire flash erases. So these kind of things, just have a look at it. So usually devices won't have it, but if you go deeper and look at a better range of devices, you might find some of the devices having physical tampering protection. Then you also might encounter a number of different kind of screws. I think there's a resource available online on all the different types of screws that are present. So make sure that your screwdriver kit has like all sort of necessary screwdrivers to open up the device. Then once you have opened up, just from a normal perspective, look at all the different components and identify the name of the various components. So if I, yeah, so for example, if you look at this device, so this is a Wink hub. So as soon as you open it up, you might find a bunch of useful information. So there's something that says UART, and then there's something that says like Z-Wave and JTAG and NAND flash and so on. So even though if it's not labeled over here, even then you can simply read off the names which are mentioned on the chips, right? And that is, and once you have the names, you can simply go online, look up at the data sheet, figure out what exactly needs to be done, right? So the very first vulnerability that you can identify is looking for the serial communication protocol, or UART. So UART is something which is extremely useful for pen testers, because in most of the cases it gives you things like debugging information, or like debug logs, or even unauthenticated root shell. So that is extremely useful. So once you open up the device, try to find out TX, RX, and ground, which are three pins which are useful for any UART communication. Then figure out what baud rate do the devices communicate on. There are tools like baudrate.py by Craig Hefner, which you can use in order to easily identify the baud rate. And once you have identified the baud rate, you can simply run a utility called minicom to get the shell access. So I'll just show you a quick demo. So in this case, I have an IP camera connected to my system. So if I look at my slash dev slash directory, I find a TTY USB 0, which is a USB TTL or an RTFI badge or any device containing an FTDI chip, which is connected over here, which we'll be using to connect to the target device. The next thing that we'll do is use a utility called screen in order to connect to that particular device. So sudo screen, giving it the ID dev usb 0 and a baud rate which we think would might work. In case it doesn't work and shows us unreadable character, we will move to another baud rate. So if you look at the screen now, it just shows us some unreadable characters, right? So this is not the correct baud rate. Pretty easy to identify. So next, you simply try it with another baud rate. There are just like 5, 6 standard baud rates, and that is what most of the IoT devices operate on. So as soon as you see we have on this baud rate, everything readable, and as soon as the device starts booting up, you get all the debug messages. And at the end, you also get a root shell, right? And this is just connecting 3 wires to the open device, the TX, RX, and ground pin, and you get a unauthenticated root shell. So yeah, it's as easy as this. So let's see if, yeah. Yeah. So the next thing that you can look for is something called as JTAG, which is a bit more complicated than UART, but not like extremely, but not like super complicated. Uh, there's also a couple of issues identifying JTAG, so you can't actually identify JTAG pins very easily as you would do in UART. So one of the options is using things like JTagulator by Joe Grant in order to figure out all the individual JTAG pins. And all you need to do is simply connect all the wires to all the pins that you think are JTAG pins and simply run the JTagulator utility. And you don't have to do anything more, right? And it will tell you what are the individual pins, right? And once you have identified JTAG, then you just have to run these two commands. So one is OpenOCD in order to connect to the target device, specifying that you want telnet at port 4444. The first device is a FTDI chip, which is Artify batch. And then the other device, which is specified by the second -F, is the configuration file for our target chip, right? So you just look at the chip, figure out like if it's STM32, so you just go to OpenOCD wiki and then download the stm32.cfg and use it over here, right? And once this command runs, you can simply run telnet localhost 4444. And from there, you can dump firmware, you can debug binaries. Like in this case, we were debugging a binary real time and manipulating authentication and actually bypassing authentication in this case, right? So it's not that complicated. So let's, uh, uh, um, yeah. Yeah. So we'll jump to the questions later on because we have a lot of information to cover at this point of time. So I just want to make sure that I'm able to share everything that I have so that it's extremely useful for you. So the next thing that you can do is actually dump the flash from the device. So what, like I mentioned, once you have opened the device, you can look at the various chipsets. And one of the things that you would find is an SPI chip. So in this case, we have just desoldered the chip from the target device and soldered it on our own custom adapters. You can also build your own custom adapter. And the reason why we are building a custom adapter is because the pins or the legs of the SPI chip are extremely small to put in your jumper cables. But yeah, you can get a custom adapter from Amazon or any of the electronic store as well. And once you have the custom adapter, you can use utilities like FlashROM or SPI Flash to dump the entire flash, which would most probably contain the entire firmware in your case, right? So that is how, that is like a couple of different ways in which you get things like unauthenticated root shell, the entire firmware content, the entire flash content, and the ability to real-time debug binaries on running on the device, right? Which is pretty powerful, right? So also a couple of other things. I won't go a lot in depth into these because just to provide you information, like this is also something that you can do. So things like NAND glitching is also something that you can possibly do. And glitching simply means that you provide or bring a faulty condition in the target device. So let's say if the bootloader is running on the device and it is about to boot the kernel, then all you need to do is short 2 pins and make the kernel booting failed. And in that way, you would be able to retain the bootloader shell, which you can then use to get like root access or shell access, right? So once you have dropped to the bootloader shell, you can also add things in order to bypass authentication. So like in this case, it is asking for a username credential. And since you're in the bootloader prompt, you can also add a value called single, which would make the device boot in a single user mode. And since it's booting in a single user mode, it wouldn't ask you authentication in that case, right? So things like this, right? So that was all about a quick crash course on embedded device hacking. There are also a number of other things that you can do in embedded device hacking. So things like even side channel attacks and all of that is also something that you can look into if you are interested. The next thing that we'll look at very briefly is firmware hacking. And firmware is pretty much all the code that is running on the device. And also, if you're good at reverse engineering, you'll also be good at identifying vulnerabilities in firmware. And a lot of firmware or a lot of devices actually run on ARM and MIPS based architecture. So having a knowledge of ARM and MIPS assembly is also something that I find to be like really useful. So some of the things that you can find in firmware is sensitive hard-coded values, API keys, API keys, encryption mechanisms, verification process, whether the device is doing the integrity check and all of that or not. So the first thing that you can do with the firmware is simply go ahead and extract it using binwalk. And once it has extracted, run a tool called firmwalker in order to identify potentially interesting aspects to look at. So binwalk extracts the file system out of the firmware. And then if you run firmwalker, it will tell you like, these are the different config files. These are the shell scripts. This is where I found this, which might be interesting. And then you can manually look into all of that. Another thing you can also do is use a tool called firmware modkit, which accepts a firmware binary and then decompresses it or like extract the file system from it. And in that case, you can actually modify the file system and put it back into the firmware image and then reflash the modified firmware. So you can add things like bind shell, you can modify certain security parameters, which would allow you to debug or analyze the device in a much better way. You can also check whether the device actually accepts firmware modifications and if it is doing the signature and integrity check or not. So extracting the firmware is what we have already covered. What if the device is using encryption? So this is one of the examples. So this particular device, N300, was using encryption. But if you look at the encryption, let me quickly share my full screen. Yeah. So if you look at the encryption, yeah. So this is encrypted n300.bin. If you run binwalk on it, you'd simply get no value out of it. And that's because this firmware is encrypted. But if you simply do a hex dump on this one, let's look at the last 10 places. And if you notice that a lot of values are being repeated over here, and this pretty much signifies in a lot many different cases that it's a XOR encryption, because when you use a XOR encryption, it whenever like there's an empty space and it tries to encrypt it with the same key, you get the key itself. So now that we know that this is the key, we can use a script such as XOR decrypt.py, and you can place the key over here and you can get the decrypted firmware, which you can then use to analyze. Right. So let's go back to the presentation. So far is everything going good? And how do you guys like it? Feel free to put it in the chat. The next thing that we can look for is hard-coded sensitive values. So one of the devices I was pen testing recently, it was pretty ridiculous that they so whenever they tried firmware upgrade via their, and they had this code within their firmware, so they tried downloading it from the FTP server and they put in the credentials to the FTP server within the firmware itself. And the reason why they did it is I believe that they didn't think that anyone would care to actually look in their firmware or anyone would have the ability to look in their firmware, which is not true, right? So you can find a ton of hard-coded sensitive values, API keys, private SSL certs, staging URLs in a number of cases, and additional informative additional binaries to perform reverse engineering. So if you simply load up a couple of binaries in IDA, so for example, this is a binary. We simply look at the disassembly. You find that there's a hard-coded credential. So there's the root, which is username verification happening, strcmp. If it matches, if the username matches, it goes to the next block where it matches the password, which is 519070, right? So you can find flaws like this extremely easily. In this case, this is a command injection vulnerability, which is simply accepting user input values, passing it to the system, and then finally going ahead and executing it, right? So another thing that you can do is if you want to go actually deep into it, you can actually do things like ROP. ROP on ARM and MIPS are a bit different if you are familiar with doing it on x86. I plan to write a couple of articles to help simplify this because I haven't seen a lot of useful content around ARM and MIPS ROPing. So for example, in this case, if you look at this particular scenario, what we are actually trying to do is perform a ROP-based exploit. And in case of MIPS, we actually have to jump to things like sleep first to clear the cache and then jump to our target function. So the value 34 is being loaded into A0. And if you look at the rest of the disassembly, it is also setting other values like 80 is going into S6, 78 is going into S4, and so on. And finally jumping. Then we jump to the next instruction, where in this case, we make the instructions jump to sleep with a A0 value, which is taken as an argument. So A0 to A3, the registers, the first four registers are the actual argument, both in ARM and MIPS, right? So it jumps to sleep. And in the next couple of instructions, we ask it to jump to system. And if you look at the argument that it jumps with is S3. And if you look at the very first instruction, we were also able to control S3 via what we had on the stack. So we jump to sleep first, clear the cache, and then we jump to system with the address of bin/sh, and then we got the shell. Right? So this is something that you can also try doing it on your own, right? So next we actually come to looking at mobile applications. Mobile application, the same way as you would look for a normal mobile application vulnerability, uh, you need to look the exact same way. For example, in this particular case, let me share the screen again. So for example, if you look in this case, in this mobile application, so if you unzip the smart-wi-fi.apk, which is an APK of a smart plug socket, if you go to the smart Wi-Fi folder or SW unzip folder, inside lib, inside RMABI, you find a native binary, which is libndk underscore 3.so. You can also do things like readelf just to make sure it's ARM. So you can see that it's for ARM-based architectures. And now we can load up IDA. So sudo IDA Q. So the free version or the demo version actually lets you disassemble ARM-based binaries. So you don't need to like buy IDA initially, at least for your initial couple of things, right? So if you open this up, change the architecture type to ARM, say okay, okay, and okay, yes. And some of the things that you can do initially is just look at the functions. And if you look at the functions over here, we see AES set key, which is the encryption that is being used. And if you look at encrypt data, which is a pretty interesting function, go down and you see this thing called AES set key, which is using R0, R1, R2 as the argument. So if you track all the arguments, you find out that this is the exact AES key. The AES encryption, the kind of encryption that is using is over here, it's 128, then there's a logical shift left. So this means 128 is logically shifted left. So it's like AES 256-bit encryption, right? So very quickly on how you can analyze mobile applications as well, right? So moving on, you can also dip for vulnerabilities. So both the current version and the previous version, you can look for what kind of security issues affect them. Next, we move on to looking at a radio communication. So this is also something that would be kind of new to you, I guess, because you haven't looked at radio communications before. But the first thing that you can do is actually look at the mobile application to device communication. So just use Burp or Charles or whatever MITM proxy, whatever you use, in order to sniff the or intercept the traffic between the mobile application and the device and figure out how both of them communicate. And in most of the cases, you would be able to find out the command that the mobile application sends to the device, which you can also, uh, okay, yeah. So is the voice audible? Just want to make sure that everything is going fine. Okay, okay, perfect. Yeah. So yeah, you can look at the mobile application and all of that. You can also look at things like MQTT. Has anyone ever used MQTT before? If you haven't used it, or if you have used it, it is also used in a lot of IoT devices. So for example, this was one of the MQTT instances. If you simply, so MQTT works on a publisher subscriber model. So you can publish to various topics and you can also subscribe to those topics. And if it is not authenticated, you can pretty much subscribe to any topic using things like a wildcard, which would allow you like reading messages from all the different topics. So this is one of the chat conversation servers where like chat conversation MQTT instances where you can see all the messages going to and from between two different users. Something in Chinese, you can actually use Google Translate. And you can also look at the pictures where they're talking about donuts, which kind of like make me feel hungry, right? The other thing that you can do is, I was looking at this IoT device earlier, which we had in our lab for pen test. So it was using MQTT in order to like had the bedroom light on and off and all of that. And you can actually publish messages to that particular MQTT server and ask it to turn the light on. And if you'd see, the light would actually turn on, right? So these kind of security issues is extremely easy to find, right? And this would make you believe like, why didn't you actually look into IoT devices earlier? Because it was so really easy and like so really vulnerable, but you didn't look into it. So I really hope that you start looking into all the IoT devices. All right. And then we move on to our next and probably the last topic, which is hacking radio, which I find to be extremely amusing and interesting, and especially because all the different vendors try to implement security in things like firmware, mobile application, all of that, but no one actually cares about radio communication security. So it's extremely trivial that you can sniff BLE communication, Zigbee communication, or normal SDR communication, and do things like MITM, replay, all of that. So hacking Zigbee, so one of the most common radio protocols you'd find in IoT devices. There's also something called Killer Bee firmware, which is extremely good, and we use it a lot. You can flash it on things like Atmel RG11 or API Mote and start sniffing Zigbee packets and replaying. So here's a quick demo of what you can actually do. So I'd skip the first couple of seconds because it's all about installing the framework. So the first thing that we do is figure out which channel is the device operating on. So we see that in this case, it's channel 20, right? And we saw that there's a new device over here. The next thing that we'll do is use ZB dump on the channel 20, give it an output file name, smartbulb.pcap, store 100 packets. And as you can see over here, like I'm doing some normal communication and the packets are being captured in the background, right? And once you have captured all the packets, then all you need to do is simply replay the packets. And this is a demo on the Philips Hue light bulb or the Philips Hue hub, right? Which is like an extremely popular device, extremely well-known device in the consumer IoT segment. So as soon as you start replaying the packets, you'd see the device, the bulb performing the same actions as it was captured for, right? So there's no replay protection as such. So yeah. Next, we move on to hacking BLE. Uh, yeah. So I was just looking at the conversations and all. Yeah. So Yeah, feel free to drop in any questions you have in the meanwhile. And the next thing that we're going to have like a quick demo on is BLE. So you can actually sniff BLE extremely easily. So using things like Ubertooth or the Adafruit BLE sniffer, you can try to sniff the BLE packets. And just to give you a short introduction, so all you need to do is figure out what handles are being written and with what particular data. And all you can do is use GAT tool in order to write those data yourself and take control over the BLE device. So let me show you a quick uh, demo of the same. So let me share the entire desktop as well as the video. So let's see. So are you guys able to see this smart lock which I have? Okay, perfect. Yeah. Yeah. So as you can see, the smart lock is currently locked. So what I'll do is, yeah, I'll just go to my VM, BLE exploitation, make sure my BLE adapter is connected. I'll just plug it in. Yeah. Connect to Linux. So I have a BLE adapter connected, and this is like a very small BLE dongle, which you can, I think, get for like $4 or $5, right? So I do a sudo HCI tool LE scan, which searches for the devices around me. And if you simply run it, you see like some of the other devices like Samsung TVs and all, but you might be able to see a couple of padlocks as well. And this is my target device, right? So I see this target device. So whenever I see a device, I want to hack it. So sudo gat tool -i -b. So to start it in an interactive mode, providing the Bluetooth address, and you connect to it. And once you have connected, so I've already sniffed the packets earlier, so I know which kind of which handlers to change. So the first handlers that we want to change is let me actually, yeah, so 0x0037, and it actually uses a two-step mechanism in order to perform any action. So if I want to unlock it, it will first ask for the passcode, and that is also transferred in clear text, as you can see in the Ubertooth or any BLE sniffer traffic. So all you need to do is provide it the passcode 567812345678, and then so you see that the characteristic value has been written successfully, and then you do 0x002D and 01. And if you notice over here, so in this, ah, so the first value was actually 0x. Let me fix this. So copy, connect it again. Okay. Yeah. So char write request, and the first value is 0x002D, 00123456781, 123456778. Let me make sure that this was the value captured in Ubertooth. Yep. And then we do a char write request to 0x0037 and 01. And if you see, the smart lock has been unlocked, right? So, and you guys thought that BLE hacking was tough, right? So let's jump back to the presentation. So yeah, so concluding things. So here's my pen testing methodology. So I don't actually look I don't look for individual bugs. I focus on the entire device. And that's why we, instead of pen testing, we try to do something sort of an attacker simulated exploitation. So how does one vulnerability leads to the other? So kind of how you do an actual pen test or an actual attack in a real life scenario. And then you'd have to look at both the macro and the micro, so all the individual components and the entire ecosystem or the entire architecture as well. And so far, like all the pen tests that we have conducted, we have had like around a 95% success rate of finding critical vulnerabilities. And it also signifies both the things that we are extremely good as well as the IoT devices are extremely insecure. So yeah, so revealing the guide. So I've also, like I mentioned, I've started working on this guide, which is available at www.iotpentestingguide.com. As of now, it's a very short list, but I'm trying to complete it in the next couple of days. So you would be able to see the entire thing in the next couple of days as well. Feel free to provide your own suggestions and inputs for the guide as well, and I would be happy to include it. And the overall thing with the guide is I want you to make sure that if you start with IoT pen testing, you know exactly what to do in each of the individual components, right? So, so just to give you an example, some of the recent devices that we targeted. So one of the smart home system, the firmware had the issue to like firmware used had a like hard coded password which was used to decrypt the firmware, and also it had update URLs. Hardware, the JTAG and SPI giving us full firmware access. Radio, the usual vulnerability, all the replay. Then you have config files revealing vulnerabilities, NAND glitching, all of that. So you can see like the common vulnerabilities that you have seen so far also exist in real world devices. And all you need to do is just start IoT pen testing, the keyword being starting up actually, right? So let's hack IoT because it won't be always like the 2017s. And this is like a really great opportunity for all of you to jump into IoT pen testing at a very, very early stage. And that is why it's so useful, right? And these are some of the things that we looked at. And thanks everyone for joining. Special thanks again to Sam, Jason, and the entire Buckrow team for having me. If you want to have future conversations on Twitter, reach out over here. Additional email, learning kits, and the pen testing guide. Again, thanks everyone for joining.
That was awesome.
Yeah,
Thank you so
thanks.
much,
Thanks.
Aditya. Everyone's like flipping out in the chat in a good way.
Yeah.
Unfortunately, we don't have much time, or we can't really dive too much into questions, but definitely hit him up in Twitter on Twitter. His Twitter username's right there, ADI1391, and ask him questions. We'll also we'll probably do a forum thread on the Bug Crowd forum later when we post the videos, and you can ask Aditya some more questions.
Sure, sounds good.
But this was great. Again, we have IoT bug bounties on Bug Crowd that need awesome people like everyone out there that's watching right now to hack on them. We've got Netgear, we've got Aruba, we've got Barracuda, we've got all kinds.
Yeah, and I would expect like you would see a sudden rush of vulnerabilities in the next few months, I guess.
I hope so. I hope so.
Okay,
Well,
so yeah,
thanks.
thanks a lot.
Thank you.